Hello guys, welcome back to Maison African Motives. We are still on our exponents and logarithms. So in this platform, we've got a question that you're going to consider. Question number 3. There we have got different typical questions. As we can see that we are given to simplify, to solve, to simplify, this and that. All right. So given question number 3.1, simplify without the use of a calculator. So meaning to say you are not required to use a calculator there. So we are given 15 to the exponent of x plus 1, which is multiplying 9 to the exponent of 3x minus 1 times 25 to the exponent of x. And this all part is over 45 to the exponent of 2x times 27 to the exponent of x minus 1 multiplied to 5 to the exponent of x. Remember, I talked about this and said whenever you have this condition and you're asked to simplify, try by all means to write your numbers as numbers in simplest form, which is the prime numbers. The prime numbers are the numbers that are in simplest form. Prime numbers. Which numbers are we talking about? 2, 3, 5, 7, 11, these are prime numbers, divisible by 1 and itself. So this is what you're going to ask yourself. 15, is 15 a prime number? No, 15 is not a prime number, but we can express this as a product of two prime numbers, 3 and a 5. So this 15 that we are seeing here is the same as we've got 3 times a 5 to the exponent of x plus 1. 15 that we are seeing there, 3 times 5. All right, we have got the same thing multiplied to 9 to the exponent of 9 is not a prime number, but 9 can be given as a prime number, which is 3, which is 3 to the power of 2 already. 3 times 3, that is 3 to the power of 2, that's 9. So in place of this 9, we've got 3 to the exponent of a 2. So that's 3 to the exponent of 2 to the exponent of 3x minus 1. So this is what you're going to have. And moving on to 25, the same thing. 25 is not a prime number. So as a prime number, that is 5 times 5. So 25 is same as 5 times 5, which is 5 to the exponent of 2x. All right. We have got the same thing on this part, 45. 45 is not a prime number. If you were to express 45 as a product of its prime factors, you are going to see that the smallest number was going to be a 3. If you divide 45 divided by 3, that's a 15. You divide again by 3, 15 divided by this 3, that's a 5. You divide by 5, 5 divided by 5, that's a 1. Meaning to say 45 as a product of its prime factors, this 45 that we are seeing here, it is equivalent to the product of 3 times 3 times a 5. 3 times 3 times a 5. These are prime numbers. 3 times 3 is same as 3 squared times a 5. So meaning to say, where I am seeing this 45, I'm seeing 3 to the exponent of 2 times a 5, which is being raised everything to the exponent of 2x. All right, the same thing here. Don't be scared there, guys. There's a times there. A dot is just a times, all these dots. So thus 45 can be written as a product of its prime factors. You're supposed to write these numbers as prime numbers, the simplest number on earth. Like I always say, is a prime number because it's just one in itself. All right. 27 to the exponent of x minus 1. 27 is not a prime number. So as a prime number, 27 is same as 3 to the exponent of a 3. 3 times 3 times 3, 3 times. But there is an exponent of x minus 1. Multiply to 5. 5 is already a prime number. So there's nothing that we are going to do on this 5. It's already in simplest form. So this is what we are going to have. So considering this part, we are going to see that by expressing these numbers in simplest form, we can see that there's a 3, there's a 3, there's a 3, you see that. It is easier that way. If you write your numbers in simple, it is going to be automatic, that thing. So this is the idea now. Remember, we talked about this, that if you are given terms, numbers that are inside a bracket, raised to a certain exponent, it means everything must be raised to that exponent. Xy to the exponent of m is x to the exponent of m, y to the exponent of m. Everything inside of the bracket is being affected by this exponent. And when we are given an exponent and an exponent, I said you're going to multiply exponents. From which concept? X to the exponent of m raised to the exponent of n is going to be x to the exponent of m, n. You multiply. So meaning to say, in this case, we are going to have the 3 and the 5 together inside of the bracket, just like xy. Raised to the exponent of m, so you're going to have each raised to the exponent of x plus 1. So that is 3 is going to be raised to the exponent of x plus 1. Everything inside the bracket. So 3 to the exponent of x plus 1 times a 5 also raised to the exponent of x plus 1. So that's 5 to the exponent of x plus 1, like that. On this part, there is an exponent, an exponent, an exponent, an exponent. You multiply them together. So that is, you're going to multiply these. 2 is going to multiply everything inside of this bracket. So this is 3 to the exponent of 2 times 3, which is 6x. 2 times minus 1, which is a minus 2, times 5 to the exponent of 2x. So we have simplified everything on the numerator. All right. With the same concept, we are going to simplify the denominator. So this is everything over. We have the same thing here. This part raised to the exponent of a 2, just like this part that we had before. If you are given xy to the exponent of m. So that means 3 to the exponent of 2 is going to be raised to the exponent of 2x. So that will be 3 to the exponent of 2 to the exponent of 2x, like this. So it's 2 times 2, which is going to be a 4x. So that is the idea there. All right, sorry for that. So this one is going to multiply 2 and 2. That will be a 4x. So 3 to the exponent of 4x times the 5 is going to be also raised to the exponent of 2x, which is outside. So that is 5 to the exponent of 2x. This is the same as 5 to the exponent of 1. So it's 1 times 2x, which is just 2x. But on the 3, it was 2. So it's 2 times 2, which is going to be a 4. All right. On this part, exponent, exponent, you multiply exponent, exponent, you just combine them together by multiplying. So this is 3 distributed inside of the bracket. So you're going to have 3 to the exponent of 3 times x, which is going to be 3x. 3 times minus 1, which is minus 3. Multiply to 5 to the exponent of what? Of x. There's nothing that we can do there. So this is what you're going to have. And if you do not want to have confusion, just simplify the numerator on its own. All right, on the numerator, you can see that there's a part of x. I mean, the part of 3 raised to a certain exponent, 3 raised to a certain exponent, 3 raised to, we have got that part. The base of 3. This is the part that I'm talking about here, the base of 3. We know that if the bases are the same and you're multiplying, because this is under a multiplication, everything on top is under a multiplication. So we're going to add the exponents. We're going to add the exponents. So this is 3 to the exponent of what? We're actually going to add. You're supposed to add 3 to the exponent of x plus 1 plus you add to this exponent where there's x, which is 6x minus 2. So what are we going to have? X plus 7 plus x plus 6x. This is 1x like this. So this is 1 plus 6, which is a 7. So that's 7x. We have got 1 minus 2, which is a minus 1. So that means we're going to have 3 to the exponent of 7x minus 1 multiply 2. You do the same thing on the 5. This 5 here, the base of 5, base of 5, you're also multiplying there. So considering the case that you are multiplying, and I said whenever you are multiplying, what are you going to do? You're going to add the exponents. So you're supposed to add x plus 1 plus 2x. So this will be a 3x. That's 1x plus 2x, which is 3x plus a 1. So this was going to be 5 to the exponent of 3x plus a 1. So with the same concept, we are going to affect also the denominator. With the same concept, so meaning to say on the base of 3, the base of 3, you're going to add because you're multiplying these. So what are you going to do? Add exponents. So this is 4x plus this exponent 3x minus 3. So 4x plus 3x, that is going to be a 7x minus 3. All right, so this is going to be 3 to the exponent of 7x minus 3. On the 5, we do the same thing, but as we can see on the 5, it is just direct here. This is 1x, we're just going to add 2x plus 1x, so that will be 5 to the exponent of 3x. So you combine this to this. You're multiplying there the bases that are the same. So what are you going to do? Add exponents. So this is the idea there. Now that we are left with these, considering the bases of 3, we'll see that there's a 3 here, there's also a 3. But this time, what is happening is that we are dividing. The 3 is in the numerator, another is in the denominator. We are dividing. So when you are dividing, the opposite now, you're going to subtract. So it was supposed to be 3 to the exponent of 7x minus 1. We subtract this. And as you are subtracting, open a bracket. Always take a negative with a pinch of salt. Whenever there's a negative, open a bracket. The negative affects everything. So this is 3 to the exponent of 7x minus 1. Minus times this, that's minus 7x. Minus times this, that's a positive 3. So that's 7x minus 7x cancels. Minus 1 plus a 3, that is a 2. So meaning to say, on the part of 3, we were going to obtain 3 to the exponent of 2 times. You move on to the 5, you do the same thing. You are dividing the bases that are the same. So what are we going to do? We are going to subtract the exponents. 3x plus 1, we subtract 3x, but 3x is a single term. There's no need for me to open a bracket, but like I said, a negative, just take it with what? A pinch of salt. So that is 3x minus 3x, which is a 0 there. So meaning to say we are left with 5 to the exponent of a 1. 5 to the exponent of a 1 means that's a 5. That's simply a 5. So meaning to say we have got 3 squared times a 5. And what is 3 squared? 3 squared is 9. That is 3 times 3. 3 squared, that's a 9. 9 times 5 is what? 45. That's the idea there. So meaning to say at the end, we were going to just obtain a straight 45 from all this simplification. So you see, exponents understand each and every stage of your simplification. As you are simplifying each and every stage, it's all about the laws. There are laws to be considered. There is every step, there is a law that is supposed to be with that step. You don't just answer. There is a law that is used. There is a law. All right. 3.2, solve this. This is an exponential equation where we are given 3.2. 3x to the exponent of 3 over 2 is equal to 81. Remember, I said when dealing or working with exponential equations and the x is given on the base like this, what you need is to get rid of this exponent. But you don't just get rid of this exponent. We must have a single term. We must just remain with a single term of x. So what is affecting this single term? You will see that it is this 3, which is multiplying. So how do you remove the 3, which is multiplying? you divide. So you're going to divide by 3 both sides. X to the exponent of 3 over 2 is equal to what? So if we divide, that is going to be a 27. All right. So there we are going to obtain a 27. Okay. So what we understand is that we are supposed to remove this exponent on this side. This is what you're going to do. You must remove this exponent so that you remain with x. And I said the reciprocal or the inverse of that exponent, y 3 over 2. The reciprocal, you just interchange it, or just 1 over that number. That's the inverse of a number. Inverse. Or the reciprocal. It is just 1 over this number, just like 1 over 3 over 2 like this. So 1 over 3 over 2 is going to give us 2 over 3. So just even on your calculator, you can just do that. All right. So this is the idea there. So let me just do this. All right. My calculator is fixed. Let me just change this to the normal mode. All right. Just like this. 1 over the fraction that you're given, 3 over a 2. That's how you get the inverse. That is going to be a 2 over 3. So the inverse, when multiplied to its original number, that is 3 over a 2 like this. If you multiply it to the inverse, which is 2 over 3, remember I said our inverse is 2 over 3, look what's going to happen. You get a 1. That is the purpose, because we know that x to the exponent of a 1 is same as x. X to the exponent of 1 is same as x. So if I have this, it's an advantage. So that is how you find the inverse. So you find the inverse or the reciprocal with that inverse, which is the 2 over 3. We saw that if you multiply by that, this is going to cancel. So the inverse, we are going to raise it to the left-hand side to remove this, and also raise it to the right-hand side. Remember, it's an equation. Even if it is an exponent, it's an equation. Whatever that you do on the left-hand side, you do it on the right-hand side. And we know the purpose of doing this is that this is going to give us a 1. Remember, the original number to its inverse, that's a 1. Or you can even multiply there. You see that that's a 1. All right. So this is equal to, so we are supposed to simplify 27 to the exponent of 2 over 3. Like I said, as long as you're simplifying exponents, deal or work with the simplest numbers, which are prime numbers. So 27, can it be written as a prime number? Yes. 3 to the exponent of 3. That's a 27. So meaning to say, in place of this 27, we can have this as 3 to the exponent of 3, but being raised to the exponent of 2 over 3. So if you have simplest number, you will see that it is going to be, it is just going to flow, because you're working with simplest values, prime numbers. Everything is just going to flow. All right. So this is it here, guys. We are now back to the same concept. An exponent and exponent. What's going to happen on this part? Exponent, exponent. Remember, you multiply. So this is it on your calculator. Multiply 3 times 2 over 3. That is going to give you a 2. So meaning to say you are left with 3 to the exponent of 2. If you multiply this, and 3 to the exponent of 2 means 3 times 3, which is a 9. That is the idea there. So x is a 9. If you are to substitute the x there, you are going to see that a left-hand side, if you substitute that x, it is going to give you exactly what is on the right-hand side. Exactly what is on the right-hand side. All right, so that was our question there. All right, 3.2, simplify with the aid of logarithmic laws and logarithms to the base of 10. They specifically mentioned this time that you are supposed to work with the base of 10. It's not just use logs, no. They mention. So this time we are supposed to use log, not ln. Because ln, remember I said ln x is a logarithm in the base of e, not base 10. So this time we are supposed to use the normal log. Okay? So how do we simplify this? How do we find the value of x, 3.3. X is given that it is equal to 912.8 times the cube root. So this is the cube root of 4, 5, 6, like this, everything over 8.1 to the exponent of 4. This is what you're given there. And you're asked to simplify this. So this is what I want you to understand. Before you apply your logarithms, it is best that you write these as exponents, whatever that you have. If you've got the cube root, the square root, write them as what? As the exponents. So this is x is equal to 912.8 times, remember the cube root means to the exponent of 1 over 3. So this is to the exponent of a third. Everything over 8.1 to the exponent of 4. So everything is raised in terms of exponent. This is same like exponent of 1, so it does not affect anything. So you introduce your logarithms. Remember, this is, you're supposed to work with the logarithms. So you're supposed to introduce what? Logs. And they were given the one of the best of 10. So you're going to introduce a log on this side. You introduce a log on this side. So this is it. Once a log is introduced, I said, forget about how the question was before. Once a log is introduced, you are supposed to be very, very careful because you are now using the laws of logarithms. Once a log is introduced, we are now back to the laws of logarithms. What are these laws? All right. Remember this here, we are dividing what we have here. The numerator to the denominator, we are dividing. So the question is, what made us to do this before? What made us to have something like this, a division in our logarithms, the logarithm of A over B? Like, what made us to divide A and B? It is because we were subtracting the logarithms before. It was log A minus log B. Same as a multiplication, what made us to multiply the numbers under a single log? It was because you were adding the logarithm. Take note, you were adding the logarithms, not the numbers. You were adding. What is going to happen if we are given this as log A to the exponent of n? If there is an exponent, you're going to drop this exponent to multiply a log. It was n log A. Then this exponent, it's a number which was multiplying a log. So it's a reverse. So let's start by separating the numerator to the denominator. There is a division there. We are dividing. This whole thing is being divided. A over B. So it means we are subtracting the logarithm of the numerator. In the numerator, there is 912.8, which is being multiplied to 4, 5, 6 to the exponent of 1 over 3, like this. This is the numerator. Minus log B, log B. B is the one that is in the denominator. The denominator is what? 8.1 to the exponent of a 4. That's an exponent, this one. So we have separated the numerator and the denominator. But as we have separated, look what is happening from what we had from the numerator. There is a product there. A product means what? You were adding the logarithms, the log of A plus the log of B. A product, you were adding the logarithms. So that means the logarithm of x is equal to, you add, so it's going to be the logarithm of 912.8 plus the logarithm of this. You are adding now the logarithms 4, 5, 6 to the exponent of a third. Minus already this one, it says so it's on its own. The logarithm of 8.1 to the exponent of what? To the exponent of a 4. That is what you have there. So if you are to check, the last law that you are left with is whenever there's an exponent, you are supposed to drop this exponent to multiply the log. The exponent, it's a number which was multiplying a log. So it means you are having the log of x, which is equal to, here there's no exponent, so just going to rewrite as it is, the logarithm of 912,8 plus, on this one, there is an exponent, so I have to drop this exponent to multiply the log. There is a 1 there, so it's 1 times a third, so this is going to be a third, the logarithm of 456. We do the same thing on this 4. We are going to drop this 4 to multiply the logarithm. So it's going to be minus 4, the logarithm of 8, 1. That is the idea of the question. Showing all or each and every step. Each and every step. So you must also indicate to the examiner, what is this? What is this? What is this? You ought to indicate that to the examiner. All right, so this is it. So I'm going to have my answers to 3 decimal places. Having my answer to 3 decimal places, that means I can also change it on my calculator. Shift, set up, go to the fix on number 6, 3 decimal places. All right, you press a 3. So let's start with the log. That's the logarithm of 912,8, like this. Close this bracket. That's 2,60. All right, so this is 2, guys, well, how am I reading this? 2,96, 2,960. All right, so this is 2,96. A third log, so this is going to be plus. All right, there was a 0 there. All right, no problem. A 0, guys, does not affect. All right, so 1/3, a log of this 456, like this, 456. That is going to be 0,886. So that's 0,886. Minus 4 log 8,1. So this is 4 log 8,1. There is 8,1 there. 4 log 8,1. That's going to be 3,634. 3,634. All right, so that is it. So what you're going to do is to combine everything on the right-hand side. So combine everything on the right-hand side. We are going to obtain what? That's 2,96 plus 0,886 minus 3,634, like this. So this will give us 0,212. So this is 0,212. So it follows that the logarithm of x is equal to 0,212, which is what we are obtaining from these values which are being rounded off values. And I say that a logarithm, it means we are already, if we're having a log like this, it means we're in the base of 10. So remember that you can convert this to be written as an exponent. So it follows that this x is equal to the base to the exponent of the answer that you're given. The base, always the base to the answer. So the base is 10 to the answer, 0,212. Or if you've forgotten this, this is how you can remember this. On your calculator, you will see that we want an anti-log, which is the reverse of, like, the opposite of what you have. So you were using a log before. This is where a log is. You see this log. On top of a log, there is what? 10 to the exponent of. So this is how you can remember how to remove this. You remove with what is on top of a log. If you are using a ln, what is in top of a ln? It's e. So to find the exact value, it will be e to the exponent of an answer. That is, if you were working with a ln, but we were not using ln, we are using log. So on top of a log, there's what? 10 to the exponent of. So it's shift that log, that is 10 to the exponent of the answer that you have. This is exactly what we have here. So that is going to be 1.629. So this is the value of x that you're going to have. So x was going to be 1.629. So it's actually an approximated value. So if you calculate it from this one, you're going to have a number at this one, if you use your calculator to simplify this, you get the exact answer. This one is just an approximate value, but we are calculating x from our log. That is what you're supposed to have. So this is how you use your logarithms to calculate the value of a certain number that was supposed to be used in form of another simplification, but you are now opting for logarithms. So you just have to work with more questions. So that was it, 4 marks for that. All right. 3.4, solve for x in the following equation using logarithmic laws. This one is all about the laws. So we are given 3.4, the ln of x plus 4 is equal to 2,302. And you're asked to use the logarithmic laws. Which logarithmic laws are we talking about? We know that, I talked about this before, whenever a ln is, it means a logarithm in the base of e. So if you are given a ln of something, it's log of that in the base of e. So this simply means whatever that we are seeing here, it is the logarithm of x plus 4 in the base of e. That makes it to be a ln, this one, in the base of e. So this is equal to 2,302. This is what you're given on the right-hand side. Remember how you remove a log, like what we did on the previous part. This here, x plus 4, must be equal to what? The base, always the base to the exponent of the answer. So it's e to the exponent of the answer, 2,302, just like that. So meaning to say I can calculate x. If I transpose this positive 4 here, it is going to subtract on the other hand. So x is going to be e to the exponent of 2,302. The 4 taken to the other side of the equation is going to be a minus 4. It was adding. So on the other side, we are going to subtract. So it's just like you are transposing, but solving for x. So this is you and your calculator. So meaning to say, we can simplify this just on your calculator like this. E to the exponent of, that's shift on top of a ln, there's an e there. So it's e to the exponent of 2,302. Okay, then just move this, subtract a 4. All right, so that is going to be 5,994. So this is 5,994. That is the value of x that you're going to have at the end. So just like that, just like that. These are typical questions that you need to know, understand, work on as an individual. As long as you are working with exponents and logarithms, expect something of this nature. They are going to ask something of this nature. So more to come from Mason African Motives till we meet again.